Now today we will see how do we solve logarithm equations. Now the main idea here is that we're going to use the definition of the logarithm where let's remind ourselves what the definition of the logarithm. The definition of a logarithm is, let's say you have a log that has base x, and a. Let's say you've been given an equation like this. This logarithm, you can rewrite it as base of the logarithm, which is b, exponent a equals what's inside the logarithm, which is x. This definition of the logarithm was defined when we were looking at the watt power lesson. So if you're still unsure about this, go back and look at the watt power lesson. But we're going to use the definition in order for us to solve logarithm equations. So let's get started. Now here we have an equation which has a log on it, and we want to solve this. So forget the parentheses there. All right, excellent. So we want to solve this. We want to leave x by itself. And notice that this x is inside the logarithm. So first, we want to rewrite this equation using the definition of the logarithm. So let's do that. Now, you're always going to start with the base. In here, the base of the logarithm is 5. So we're going to have 5. All right, excellent. So let's write that 5. So we have 5. Now, what's going to be the exponent of that 5 is whatever we have it equal to, which in this case, the logarithm is equal to 2. So now we're going to have 5 exponent 2. And now this equation is going to be equal to whatever we have inside the logarithm, which in this case is 7x. So using the definition of the logarithm, we can rewrite the top equation as 5 to the second equals 7x. So let's rewrite this. We know that 5 to the second, that's 25. So now we have, well, let's rewrite that. So we know that we have 25 equals 7x. And then if you want to solve for x, then we're just going to divide 7 on both sides. So now we know that x is equal to 25 over 7. And that's it. This is the value of x. Again, we use the definition of the logarithm to rewrite the equation. And now that it is rewritten, then we're just going to apply our algebraic rules to solve for x. So let's try another example here. Let's look at example 2. It looks intimidating, but we can still apply the same rules. What are those rules? Well, first, if what you're looking for is inside the logarithm, we need to use the definition of the logarithm. So let's apply the definition of the logarithm. Here, the base of the logarithm is 2. So now we're going to have 2. Now, what is going to be that exponent of 2 is whatever we have it equal on the right side, which in this case, we have it equal to 5. So that means that the 2 is going to have an exponent of 5. And we're going to set it equal to whatever is inside the logarithm, which in this case, we're going to have the whole thing, 5x plus 7. So we're going to have 2 to the 5th equals 5x plus 7. Okay, 2 to the 5th, we know it's 25 equals 5x plus 7. And then we just use our Algebra 1 skills to solve for x. Well, let's take away 7 here. Take away 7 on both sides. Now we're going to have, what is this, 25 minus 7, so that's 18. So we're going to have 18 equals 5x divided by 5 on both sides. So now at the end, we know that x is equal to 18 over 5. Again, all we're doing is we're applying the definition of the logarithm in order to rewrite the function. And after we rewrite it, then we just solve using our algebra skills. So let's look at another example here? I guess not. That's the next slide then. Good. So example 3. Okay. So now notice that in example 1, there was only one log. Example 2, we have one log. But now here in example 3, we have two logs. So how can we still solve for x? The easiest way for us to solve for x is try to compress these logarithms. You got to remember back to the properties that we saw for logarithm. We know that if you add in two logarithms, you can just multiply the insides. So let's rewrite these two logarithms, because log of x plus log of 8, that's basically log of x times 8. This is because of the rule of, or the properties of logarithms, which we have seen previously. Now that you have written as a single logarithm, then we can use the properties that we were using on example 1 and example 2. And again, this was mentioned in the previous video that if you do not see a log on it, there's always going to be a base, and that base is always going to be 10. So now that we know that, we have one single logarithm. We know that the base is 10, so we can apply the definition of the logarithm now. So now here, what's going to be the base? The base is 10, so we're going to have 10. What's going to be the exponent of that 10? Well, that's whatever it's equal to on the right side, which in this case is 2. And what is this going to be equal to? This is going to be equal to whatever we have inside the parentheses. But now, x times 8, that's pretty much the same as 8x. Again, x times 8, this is the same as 8 times x, which we can just represent it as 8x, and that's what I did here. All right, so now let's just solve for x. We know that 10 to the second, that's 100, so we have 100 here, equals 8x. Now we solve for x, so we gotta divide it by 8. They cancel out. So now 100 divided by 8, that's 12.5. So now here we know that x is equal to 12.5. Excellent. So let's look at our final example now. All right. So what do we have here? Notice that in example 1 and example 2, we're dealing with log in example 1, log in example 2, log in example 3. But now here we're dealing with ln, where ln is the natural logarithm. And you gotta remember that ln has base e, which we're gonna call the Euler number. Excellent. All right, so this is what we have. Now, again, doesn't matter if it's log or ln, you need to rewrite it as a single logarithm. According to the rules of logarithms, or the properties of logarithms, if you're subtracting two logarithms, you can just divide what we have on the insides. So now, on the left side, log for x plus 1 minus ln of 3. This is the same as ln for x plus 1 divided by 3 equals to 5. This is because of the properties of logarithms. Now that we have it written as a single ln, then we can use the property of the log, or the definition of the logs. So, but you got to remember that here, that when we're dealing with ln, it's always going to have base e, okay? So we have e. Now that we have as a single, we know the base, then we can use the definition now. So now here, the base is e. So let's write that, e. What's going to be the exponent of e? The exponent is whatever it's equal to, which in this case is 5. And this is going to be equal to whatever we have inside the ln in this case, which is going to be this whole expression, which is going to be 4x plus 1 divided by 3. Excellent. So what do we have here? Well, what is e to the fifth? I always try to put everything in numerical representation. E, you can find it in your calculator on top of the ln in yellow. So let's find out what e to the fifth is. So per second, e, it's right here on top of ln. So now we have e, and what's going to be the exponent that I want to find out of? 5, so e to the fifth. This is equal to 148. Let's round it to the nearest 10. So we have 148.41. That's equals to 4x plus 1 over 3. Okay, excellent. So we're still not done. We want to solve for x. And because we have a fraction here, it makes the computation a little bit harder. It's just an extra step. Remember from Algebra 1, then when you have setups like this way, you can put this over 1 if it helps. And now you have a fraction equals to another fraction, so you can cross multiply. So now this is going to be 148.41 times 3 equals 1 times 4x plus 1. 4x plus 1. So we're almost done there. So now after this, we just need to do some calculation at this point. So 148.41 times 3. So we have this. Let's multiply by 3. So on the left side, we have 445.24. And this is equal to 4x plus 1 times 1 is just 4x plus 1. Excellent. So now we just want to solve for x. So we subtract 1 to both sides. So now we have, what is this? 145 minus 1. So that's 444.24 equals to 4x. We want to solve for x, so we got to divide it by 4. So whatever this is, let's subtract 1, which is what we did here. Oops. Subtract 1. So we have the 444.24, and now this we need to divide it by 4. And our final answer is x. It's not an x. So our final answer is just that x is equal to 111.06. So this is how you solve logarithm equations using the definition. So now, here's your entrance ticket. Try to solve the following.